Welcome back to MLT 115. This is the lecture material for Part 2 for Basic Mathematics. In this lecture, we'll be covering things like the number line, order of operations, significant figures, and also rounding off. Okay, so let's talk about the number line and exactly what a number line is. A number line is a horizontal line that shows numbers in order. The line can start at any end with any number, and it can extend in both directions indefinitely from the origin. The origin is the midpoint or the zero of the line. The numbers to the right of the origin or zero are going to be increasing. The numbers to the left of the origin or zero are going to be decreasing. We can use the number line when we're completing addition of negative numbers. So let's look at what addition of negative numbers would look like. So if you have a negative number added to a negative number, what's the sum going to be? It's going to be a negative number. So what's that saying? Is a negative added to a negative number is going to ultimately equal a negative number. And I'm just putting parentheses around these to emphasize the negative number. Okay, let's just say we're adding positive numbers just like we normally would. In that case, a positive number plus a positive number, of course, is going to equal a positive number, just like we normally do in any addition problem. But in this example, we're talking about a negative number. If you're adding to another negative number, the sum is going to end up with a negative number. Let's say you have the scenario of a negative number plus a positive number. You're going to end up with a difference, or the sign of the number with the greatest absolute value is what sign you're going to have to use ultimately. So let's look at some examples of this. So let's look at an example of a positive 6. Again, I'm just going to put parentheses around my numbers so we can see them a little bit clearer, plus a negative 3. So we've got a positive number adding to a negative number, and that's going to equal a positive 3 because we're going to end up with a difference, and you're going to take the sign from your largest value. Okay, another example. Let's look at another one. In this case, you're going to have a positive 3 plus a negative 4. In this case, you're going to end up with a negative answer because your larger number is 4 in this case. So you're going to end up with your sign for your answer taking on the sign of your larger number. So it's kind of like pulling of forces. The bigger the absolute number is going to win out. So that's the sign that's going to go with your answer. Let's take this example here and put it in a number line to see exactly what it would be looking like. So let's make a number line with at least 4 on each side of our origin or our 0. So let's do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So these, of course, will be negative, negative 2, negative 3, negative 4. Okay, so we're going to start out with 3 because that's our starting point, and we're going to end up taking away 4 because that's our difference. So we're going to end up hopping 4 spots. So look where we end up at negative 1, and that's our answer that we got, negative 1. That is a 1. So we just did addition of negative numbers, so let's look at subtraction of negative numbers. So first off, let's look at what you would do in a scenario where you're subtracting a negative number from a negative number. And there's a little trick that you need to remember, and you may have heard of this little trick or saying in middle school, but the saying is add the opposite. So if you remember this little trick, it'll help you out with subtraction of negative numbers. So if we have a negative minus a negative, if you're adding the opposite, what we're ultimately going to do over here is we're going to change the subtraction to an addition symbol, and we're going to change the negative to a positive. Okay, so let's look at an example of that. So our example would be a negative 1 minus a negative 9. So here we have two negative numbers we want to subtract. Well, if we're going to use the rule of add the opposite, how can we change that calculation? Well, our 1's going to stay the same. It's going to be negative. So negative 1, and we're going to change our subtraction to an addition. And then we're going to completely change our last number to the opposite. So if it's currently negative, then we're going to change it to positive. So our calculation is negative 1 plus 9. So that calculates out to 8. So our answer is 8. Okay, let's look at the second scenario. You have a positive number subtracted from a negative number. Okay, how are we going to change that using add the opposite? Well, it's going to change to the positive number is going to stay the same. You're going to change your symbol to a positive because you're adding the opposite. And your second number is going to be the opposite of what it originally was, which was negative. So now it's going to become positive. So let's look at an example. Our example is 6, because we started out with a positive number, minus a negative number. Let's do negative 4. Okay, so how are we going to change that calculation? 6 is going to stay the same, but we're adding our opposites, so our symbol is going to change to addition. And the opposite of negative 4 is just 4. So our answer is ultimately going to be 10. Okay, with multiplication and division of negative numbers, if it's the same, if the numbers are the same, if they're negative, the product or the quotient is going to be positive. Okay, so if they're the same, they're going to end up with a positive end product. But if they're different, let's say your numbers are one's positive and one's negative. One's positive, one's negative. Or either negative or positive, it doesn't matter which order they're in. The product or the quotient, being if you're talking about division, the end product is going to be negative. Okay, so if it's the same, you're going to end up with a positive end product. But if you have numbers that are different, you're going to end up with a negative end product in multiplication and division. Okay, the next concept that we need to make sure that you're aware of and remember is the concept of order of operations. This is when you have a problem with multiple steps and it involves you working that problem in the correct order. So the little trick that helps you remember what order to do things in is please excuse my dear Aunt Sally. And so each letter of each word will tell you what to do first. So if you have parentheses in a problem, you're going to work anything in parentheses first. Anything with exponents, that's going to be worked next. Then multiplication, then division, then addition, and then finally subtraction. So you do everything from left to right, but you do it in the order of operations order. Okay, so if you happen to have two parentheses in a problem, you do the parentheses on the left first and then the parentheses on the right. Okay, then you would do the exponents, then you would do the multiplication, then you would do the division, and then last you would do the addition and subtraction. And that's what it's showing down here in this example. So if you look here on the left hand side of your screen, or excuse me, the right hand side of your screen, you can see how you can come up with completely different answers to problems if you don't follow the order of operations. So let's just say they do this equation, a student solves an equation, and they don't follow order of operations. Let's just say they solve it from left to right. Let's say they do the multiplication first instead of the parentheses like they're supposed to in order of operations. Well, they're going to end up with 18 plus 4 times the 9 divided by 3. Well, that's going to end up next, again, if they're working left to right, their 18 plus 4 is going to give them 22 times the 9 divided by 3. Well, 22 times 9 is 198, divided by 3 is 66. Well, that's going to give them the incorrect answer because they did not follow order of operations. They just worked everything from left to right. But let's see how it works out if you use the correct order of operations. The same problem is being worked here, but they're working their parentheses first, their P. So next they're going to drop down and they're going to work their multiplication. Okay, so that gives them 6 times 3 plus 4 times 3, and 3's come from dividing their 9 from their 3. Okay, and then the multiplication of 6 times 3 gives them 18. Okay, then you have your plus 4 times 3, and you're going to have to do your 4 times 3 next because that's multiplication. You're going to do multiplication before you do any addition in your order of operations. So that's going to give you 12, where you can move your 18 down, and then finally you can do your addition of the 18 plus 12, and that will give you 30, which is your correct answer according to your order of operations. Okay, let's look at another example using order of operations. So the very first thing we want to do, step 1, we're going to be looking to see if there's any parentheses, and there are. We got 4 plus 5, so that's the very first thing we're going to solve, and that's 9. So we're going to do multiplication next, and we do have multiplication, so that's going to be our step 2. So multiplication of 6 times 9 is what? 64. Sorry, that's not a very good error. 64. Next, we would do any division. So step 3 is division. So division of 64 divided by 3 would be 18. Okay. Step 4 would be addition. So 2 plus 18 is 20. And then finally, our last step, or step 5, would be subtraction. So 20 minus 5 would be 15. Next, let's talk about the concept of rounding numbers off. And there's 3 different rules that we need to be familiar with. The first 2 you're probably aware of and are used to using. The third rule is going to be a little bit odd, and it's used in the laboratory. So we're going to look at some examples of all these here in just a minute. But let's explain all 3 to start with. The first one is you're going to round numbers greater than 5 to the next higher whole number. So let's look at an example of that. Let's do 3.67. So we know this 7 is higher or greater than 5. So what can we round this 6 up to? We can round this 6 up to 7. So when we round up, our answer is 3.7. The second rule is you round numbers less than 5 to the existing whole number. So an example of that would be, let's say we have 5.13. This number here is obviously less than 5, so would we be rounding the 1 up to anything? No. It would stay 5.1. The last and third rule that might be a little bit odd or different, or you may have not used before, but we use in the laboratory setting, is to round numbers equal to 5 to the next higher even number if the number is odd. Okay? And what does that mean? We have a little trick to help us remember what to do in these scenarios. And the trick is even, leave, odd, round up. Okay, so if you remember this little saying, it'll help you remember what to do in this situation. So let's look at an example. And I don't know why that zero's over there, so just ignore that. But our example would be 0.1675. Okay, so we're trying to decide whether we can round this 7 up or not. Well, we have a number that's equal to 5. Okay, and the number before the 5 is odd. Okay, it's odd. Well, what does our little saying say? Is even, we're going to leave it. Odd, we can round up. So because this number is odd, we have our 5. Guess what? We can round up 0.168 would be our answer. So you're probably asking yourself, what's the point of this third rule as far as rounding off? Why would we do this whole even, leave, odd, round up? Well, numbers for the laboratory setting have to be so precise in certain situations is if we constantly rounded our numbers up, we would be skewing our numbers to the high side or the positive side. So this rule helps us kind of keep things kind of even keel. It's not skewing our numbers. It's a way to keep our numbers more close or absolute to the true value. So let's look at some more examples of rounding off and decide which rule we need to use. So the very first number that we're going to look at is 3.19. We're going to look at our last number. Is it greater than 5? Yes, it's greater than 5. So what can we round our 1 off to? We can round it off to 2. So our answer is 3.2. In our second example, let's look at our 2. Is our 2 greater than 5? No. So this would fall under that second rule. We're not going to be able to round our 1 up to 2 because our 2 is less than 5. So our answer is going to be 3.1. Okay, now let's look at the third example, 3.15. Okay, well, guess what? We have a 5. Okay, this is where that third rule is going to come into play. 5 is behind an odd number. So 5, what's our rule? Even, leave, odd, round up. Okay, so this is odd, so we can round up. Okay, here's the next example. We also have 5. Well, look at here. We have even. What do we do when we have an even? We leave it. So we have 3.2. Okay, so we're ultimately ending up with 3.2 and 3.2 in both these scenarios, but we come to 3.2 for 2 different reasons. Okay, we had an odd in front here, and we had an even in front here. Okay, all right, we have another situation where we have a 5 at the end. Guess what? It's 3 even or odd? It's odd. So guess what we can do? We can round up. So we end up with 3.4. The next concept we must learn and know how to work with is significant figures. Significant figures is important to the laboratory because we need such precise and accurate numbers. When you're working with significant figures, whatever your number is, if it's a significant figure, it indicates confidence of accuracy within a half of point of itself, plus or minus. So now let's look at some examples of significant figures. So let's first look at 14. So if we're looking at the confidence of 14 or the accuracy of 14, it is within 13.5 to 14.5. So that's a half a point below and a half a point above the 14. So that's the range of confidence for the significant figure of 14. So the actual significant figures in the number of 14 is 2. The 1 is significant and the 4 is significant. So that gives you a total of 2 significant figures. Okay, the next example is 14.4. Again, the range of confidence is a half a step below and a half a step above. So your range of confidence is 14.35 to 14.45. The actual numbers of significant figures is 3 because the 1 is significant, the 4 is significant, and the second 4 is significant. So all 4 of those numbers within that whole complete number are significant. Now we'll go over some rules here on the next slide of which numbers are significant versus which numbers are not significant within a number. But so far, all the numbers that we've looked at have been significant. In our next value, we have 14.44. All 4 of these numbers are significant, so we have 4 figures that are significant. Again, a half a step below, half a step above is the accuracy or percent confidence that we have within that number. Okay, you add another 4 on, and again, you just add on another significant figure. So 14.444 has 5 significant figures, and again, half step below, half step above is the percent confidence and accuracy of that number. Okay, so let's look at the rules of significant figures. All non-zero numbers are considered significant. So your 1, 2, 3, 4, 5, so on, they would be considered significant. No matter where they are in your number, they're considered significant. Zeros to the right of a non-zero number are significant on either side of the decimal point. So an example would be 200. Okay, so your 2 would be a non-zero number, correct? The 0 of the 200 is to the right of the non-zero number, so they would be significant. So you'd have 1, 2, 3 significant figures, sig figs. Okay, the next example is showing you a 0.200. Well, again, 0.200, your significant figure or non-zero number is your 2, but then you have 2 zeros that are to the right of that. So these two would also be significant. This one before the decimal would not be considered significant. So again, you have 3 significant figures. The third rule is zeros to the right of the decimal point are not significant if there is no non-zero number to their left. So this one can sometimes be confusing to students. So let's look at the example, okay, and let's note where our zeros are. So zeros to the right of the decimal, okay, so we do have 2 zeros that are to the right of the decimal, correct, are not significant if there is no non-zero number to the left. Well, there's no non-zero number to the left of those two. We just have another zero. And because of that, this particular number, 0.00152, okay, we're looking at these 2 zeros. These are the ones that's to the right of the decimal. They're not going to be significant because there's no other non-zero number to the left. So we're going to end up with 3 significant figures only in this number because of the 1, 5, and 2. Those are your significant figures. Now let's look at the last rule. Zeros between non-zero numbers are significant. So if your zero happens to be caught in between some of your regular numbers that are significant, then your zero can be counted as a significant number. So in this example of 1.02, guess what? That zero is smack dab in the middle of 2 numbers that would be significant no matter what. So you end up with 3 sig figs. Okay, when you're working in the laboratory, you have to consider your results critically as a lab tech. We want to put out the best results possible for patients. So we use a lot of automated analyzers and they spit out results for us, but us as lab techs, we have to interpret those results. So let's look at an example of an analyzer that's printed out some results for us, but us as lab techs, we're going to have to consider and evaluate those results. So let's look at test tube 1. It's given us a result of 100. Okay. Test tube 2 is give us a result of 10. Test tube 3 is give us a result of 0. Okay. Let's say that test tube 4 is also give us a result of 10. Okay, so as a lab tech with a trained eye, you're looking at these results versus our test tubes. Would you report out test tube 4 as 10? And why? Okay, you shouldn't. Okay, if you're a lab tech. Look at the colors. Does the color of test tube 1 not look very similar to the test tube color of 4? Shouldn't you think the result of test tube 4 should be close to the test result of test tube 1? I would think that it would be closer to 100. It might not be exactly 100, but it's not going to be 10. Okay? So as a good lab tech, if you were to get a result in test tube 4, if you're thinking these are correct, if these results are correct, and you're questioning, oh, this result should be way higher, and you get a result of 10 on your analyzer, as a good lab tech, what are you going to do? Rerun the test, rerun the sample. Okay, you're not going to report those results out. So as a lab tech, not only do you have to keep a check on your instrumentation, is it running correctly, but you have to keep a check on the integrity of your samples, how were your samples collected, also patient history. Those are things to take in consideration when you're trying to decide do you have a good result that you can report out? Okay, some other basic concepts for lab math that you need to be aware of is that you need to use proper numerical nomenclature or unit values when reporting out results. For example, when you're writing patient results down, you need to make sure to include the unit of measurement with it. For example, if you just write a 5 down for a result, somebody might not know if you mean 5 milliliters or 5 liters. This is very critical because this could mean a significant difference for a patient. Maybe if it's a dosage of a drug, 5 milliliters is a huge difference between 5 liters. So let's look at some more examples. So if you're just writing anything down, let's talk about length. If you're talking about 3 centimeters, you wouldn't not just write 3, you'd write the cm to indicate centimeters. Another example, if you're talking about microns, let's say you pipetted 10 microns, you would include the unit of microns. Or microliters along with the 10, so somebody could go behind you and know that you pipetted 10 microns. Also, when you're working as a lab tech, you need to write clearly so everybody that's working with you or working behind you on a different shift can come in and know exactly what you have done, what you've reported out. Also, nurses, doctors can also know exactly what you've written and reported out. Luckily, most of our reporting out and charts are done electronically now, so that's took some of that writing or clerical errors out. But still write as clear as you possibly can. That kind of leads into clerical errors. If you are transferring data, whether it's written data or data that's typed to the computer, you always make sure you want to double check that everything has transferred correctly. In a scenario where you're writing something down and you haven't transferred something correctly and you do make a mistake, for example, 4, item 4 here, that you're supposed to have transferred 98 and the 9 got dropped and only 8 got transferred, you would want to make sure that you would add the 9 in. But let's say that you just wrote something completely wrong and you need to mark it out and rewrite it. The correct way would be, let's say you wrote 88 instead of 98. The correct way to make a correction is one single line, and then you're going to date it. And then you're going to initial it. Okay, so you're not going to scribble it out. So you're 88, you wouldn't scribble it out where you couldn't read it all. That's incorrect. You're only going to do one line and then date and your initials to correct it. And also, when you're performing any kind of manual calculations, just double check yourself. I hope you've enjoyed part 2 of the basic mathematics lecture. I know some students struggle in particular with significant figures in this lecture, so feel free to reach out to me through email or before after lab when we're on campus together, or come by and see me during office hours and I'll be glad to help you. Also, there's another video just on significant figures posted on Moodle, so please feel free to watch that. That might also help you. But I will see you in the next lecture.